Hello dear students, myself Mohammad Waseem, Assistant Professor in Mathematics, Art Science, Commerce College, Bandhavgarh. In previous lecture we have seen about inverse Laplace transform. Now we are studying about application of inverse Laplace transform, in which we have seen some examples which are dependent on particular theorems which are as follows, which are linearity property. Some theorems, some examples are depend on first shifting theorem. Some examples are depend upon second shifting theorem. Now today we are going to study a topic or application of Heaviside's expansion formula. Heaviside's expansion formula. For inverse Laplace transform. We have seen the definition of Heaviside's expansion formula, and which is as follows. If f and g are any two polynomial and degree of f is less than degree of g, then inverse Laplace transform of f upon g will be summation I is equals to 1 to n f of alpha I g dash of alpha I e raised to alpha I t, where alpha I are zeros of g polynomial g. Correct? It is the formula for Heaviside expansion. Now here we have two different polynomials f and g, in which degree of f is less than degree of g. Then if we have to calculate inverse Laplace transform of f upon g, can be solved by using summation I is equals to 1 to n f of alpha I upon g dash of alpha I, where g dash indicates that first derivative of g into e raised to alpha I t, where alpha I t are zeros of polynomial g. Zeros of polynomial g. Now let's see one example which is given as follows. Example number 1. Find inverse Laplace transform. Find inverse Laplace transform of inverse Laplace transform of, here is given there, inverse Laplace transform of 2p square plus 5p minus 4, 2p square plus 5p minus 4 upon p cube plus p square minus 2p. Correct? It is one? We have to calculate inverse Laplace transform of such this function. Now, if you see the definition of Heaviside expansion formula, in which degree of numerator must be less than degree of denominator. So we have degree of numerator is 2 and degree of denominator is 3. So we can easily apply Heaviside's expansion formula to solve this example. But before going to start with Heaviside expansion formula, I would like to solve this example by using partial fraction, and after solving by partial fraction we will see the next method, that is Heaviside expansion formula, and we will compromise to both methods and will deduce which is easiest and simplest method to solve such type of example. So let's start with partial fraction by using partial fraction. By using partial fraction, so take this 2p square plus 5p minus 4, or take directly p cube plus p square minus 2p. We can take p common outside. We will get p into p square plus p minus 2, and we can solve this quadratic equation. P square plus 2p minus 2, and taking p common outside, p plus 2 minus taking outside, we get p plus 2, and we get p plus 2 and p minus 1. So zeros of p cube plus p square minus 2p is 0 minus 1, sorry, minus 0 minus 2 and 1. Correct? We have found zeros of p cube plus p square minus 2p are 0 minus 2 and 1. Now we can